Okay, this section discusses what we do when we raise a power to the power. So the previous section, the exponent rule, was multiplying powers that had the same base where we added them together. Now this is saying what happens if we raise like x squared to the fourth power? Well, raising x squared to the fourth power is just saying x squared multiplied by itself 4 times, right? So if x squared is multiplied by itself 4 times, then x squared is 2 of these x's, right? Here's our 1x squared, here's our second x squared, and so on. So we can see those within our problem that I broke down here. So like this is an x squared, here's another x squared, here's another x squared, and here's another x squared. And when we add all these together, we get 8. So the rule with raising a power to the power is we just multiply the exponents. So 2 times 4 would be 8. All right, so x to the 2 times 4, that just simplifies the problem for us. So in the basic sense of what we're looking at, we just multiply whatever's out here by the exponents that are listed on the inside. So if it's just a single term, it's pretty straightforward. 6 times 3, 18, right? 4 times 7, so a to the 28th power. For those of you that are, make sure you're using your calculator to double check these. So a to the negative 4 times 7, so just think of it, negative 4 times 7, that gives us our negative 28. A to the negative 28, and then if we make this positive, we move it to the bottom of the fraction. So a to the 28th with a 1 on top, right? All right, and then over here we have c to the third, to the negative second, and c to the fifth. So this is actually kind of taking a step further. So all we're going to do is multiply this negative 2 times the 3, and we're going to keep that c to the fifth. So watch what happens here. C to the fifth, negative 2 times 3 would be c to the negative 6. Okay, so I just simplified that. Now what do? I now have 2 powers that are being multiplied that have the same base. So going back to the previous, we can add these together. So 5 plus a negative 6, what would that be? Or 5 minus 6, you can think of it that way. If I do 5 plus a negative 6, still going to give us that negative 1. So this now adds to c to the negative first power, which then to make that positive, we put it on the bottom of a fraction, 1 over c to the first power, or just c. We don't need to put that 1 there, but we can if we want. All right. So that was a little bit more involved, but it's building off. You can see how they're going to be connected when we are simplifying powers. All right, so here's some practice with these. So if I look at this, 4 times 6, so all you need to do is multiply these together. You get x to the 24th power. 4 times negative 2 would give us x to the negative 8. Again, use your calculators on these to help you simplify it. And then to make this a positive, we move it to the bottom of the fraction and call it x to the 8th. And on the top, we'll just have a 1 if there's nothing left over. All right. And I don't know why I put that one twice. That's interesting. So x to the 24th. I'm just going to leave it. I think I meant to put maybe a negative number there or something, but either way, same rules apply. Okay, so now these examples are going to go along with this one here. All right, so I'm going to simplify this one first. So I do a to the 4 and then 4 times 2, which would be 8. So I'll have a to the 8th power. And this would be 4 times 5, which would give us a to the 20th power. And now we are multiplying with the same base. That's going to give us a to the 28th because we add those together. Over here, we have this y to the second power, which is going to stay. 7 times negative 2 is negative 14, so y to the negative 14. And use your calculator on these. Don't be afraid to double check your arithmetic, because I know with negative numbers, sometimes that gets confusing. 7 times negative 2, it'll give us that negative 14. So over here now we add these exponents because we are multiplying with the same base. So 2 plus a negative 14 or you can say 2 minus 14, but I'll stay consistent by saying plus a negative 14, and that will give us a negative 12. So we would write y to the negative 12. And of course, we are going to make that a positive on our final answer. So we're going to move it to the bottom of the fraction and make it a positive 12. Put the 1 on top, and that is our final answer. All right, on the next page in notes, we are talking about raising a product to a power. Product is the answer to multiplication. So this, 3 times x for that example. Here is the part that is usually throws people off, is when you don't see an exponent in the problem inside the parentheses. But remember, if you don't see one, there is a little 1 there. So there's a 1 with that 3 and a 1 with that x. Most people will make the mistake of not associating the whole number to having an actual power, but that is the key to doing these types of problems. So we're going to multiply all numbers and exponents by the power being raised. So if you look at this example, and this little 1 will make more sense, 4 times 1 for that 3 is 3 to the 4th power. And 4 times 1 for that x is x to the 4th power. Now, in the final answer, I raised 3 to the 4th power to get 81. That's how I got that final answer. Here again, 2 times a little invisible exponent of 1. 2 times 1 is 2. 2 times 4 is 8. And then 2 to the 2nd power gives us that. All right, so let's go ahead and break this down. And now you don't see any exponents in here, so we assume that there's a 1 with each one. So this would be 2 to the 4th and z to the 4th, and then go ahead and raise 2 to the 4th power on your calculator to simplify that. So 2, that AB button to the 4th power, and that gives us 16. So this would be 16z to the 4th power. All right, so now we have these being raised to the negative 2nd power. So remember that 4 to the 1. So this is going to be negative 2 times 1 is 4 to the negative 2nd power. 5 times negative 2 would be x to the negative 10 power. And what do we do with negative exponents? Well, we move them to the opposite side of the fraction. So this would be 4 squared x to the 10th, and we put the 1 on the top. We could take it a step further, and 4 squared, we can do that on our calculator. So 4 to the 2nd power, and that gives us 16. So we can call this 16x to the 10th power, and then we have 1 on top. Okay, so how do we do that? Now we have multiple in here. So simplifying a product raised to a power. So we're going to raise all the powers to the powers and then multiply the common bases. So we're really just taking these extra steps and combining them with what we've already learned. So if you look at this one, I'm taking 2 times negative 2. That's where I get that 4. 4 to this 1, that's how I get 4 or 3 to the 4th power. 4, that goes with the x, x to the 4th. 4 times the 2 with the y, that's how I get y to the 8th. All right, so then what we do here on the next step is now we can add our same bases, right? 3 to the 4th is the only whole number, so I put that out front. Negative 4 plus 4 gives us 0. Anything to the 0 power is 1. So ultimately that goes away because anything times 1 is still itself. And then y to the 8th power is just remains y to the 8th power. Over here I simplified it. 3 to the 4th power is 81. That's how I got that. So let's look at this one and let's break it down. So c squared to the 3rd. So 3 times 2 is 6. So that's c to the 6th power. 4 times this 1 that goes with the 3. That's going to be 3 to the 4th power. And then 5 times 4 here for that c would be c to the 20th power. Right? So I'm going to put these in order a little bit. So I'll do 3 to the 4th power first. So we list that whole number first. And then c to the 6 and c to the 20. We're multiplying those, so we add the exponents. That would be c to the 26th power. 3 to the 4th power we can simplify a little bit further, which would be 81 because we did it up here, or you use your calculator to do that. So we do 3 to the 4th power, and that gives us 81. We knew that. So this would be 81c to the 26th power. All right, let's go ahead and practice these. Again, make sure you recognize that these have an exponent of 1. So this would simplify to 5 to the negative 4, y to the negative 4, both negatives, so we're going to put them on the bottom of a fraction. 5 to the 4th, y to the 4th, and we'll put that 1 on top to indicate that. If you want to take that a step further, this is optional, but sometimes the answers are listed that way. We would put 5 to the 4th power, and that gives us 625. So this could be this, or we can write it as 1 over 625 y to the 4th. All right, this next problem, and again, pause these, try them, and then see how you do. So we have 3 to the 4th power, and then this would be n to the 6 times 4, which would be 24. They are both positive, so we don't have to move them and make them positives, but we could take 3 to the 4th power and make that 81. So 81 n to the 24th, so I'll put an or here. It's either this or this would be fine for your final answer. All right, so we look ahead at this next problem. This 3, and you don't see any exponents in here, so again, assume that they're all a 1, and we're going to put a 3 with each one. So this will be 2 to the 3rd, x to the 3rd, y to the 3rd, and then bring down this x squared. All right, now we're going to combine. We're going to add the same bases. I have a 2 to the 3rd, so there's no other exponent or power that has just numbers to them. So I can do 2 to the 3rd, and you can figure that out on your calculator, or you can just say 2 times 2 times 2 and do it in your head. But if you don't do it in your head, 2 to the 3rd power, and that gives us 8. That one comes up so much, raising 2 to the 3rd power and 8 and breaking down things. We should know that 8 is 3 2s. But anyway, I'm going to call this 8. Then I have my x. I have a 3 and a 2, so we are adding those together. 3 plus 2 is 5, so x to the 5th, and y is by itself, so y to the 3rd just remains that. That would be our final answer there.